Hey guys, I hope everything is still going well for you guys. Today we're gonna finish Unit 4. Unit 4 is pretty long, so we're just gonna focus on these three concepts. We're gonna focus on our transformations, and then we're gonna focus on our angles, and then we're gonna focus on Pythagorean theorem. Okay. So this is we have our quiz for Unit 4, and then we have two more assignments, which is the vocabs for Unit 5, and then the quiz for Unit 5. I'm gonna try to get the vocabs out to you this week, and possibly the quiz and the video for Unit 5 also, so that you can finish all your work this week, so you don't have anything to do next week. All right. So let's get started on this. If you did your vocabs, you should already know we talked about four transformations this year. We talked about translation, we talked about reflection, we talked about rotation, and we talked about dilations. So we're going to be looking at reflection and rotation because those are the two that you definitely need to know going into high school next year. Okay? All right, so reflection, there's two ways you can reflect. You can reflect over the x-axis and you can reflect over the y-axis. Okay? So anytime you see this little triangle, it means the opposite. When you're reflecting over the x-axis, your original x and y coordinate, you're going to keep your x coordinate the same, but you're going to make whatever your y coordinate is, you're going to make it opposite. Okay? So let me show you what that looks like. So let's say my original coordinates were 2, 4. And if I'm reflecting that point over the x-axis, I'm going to keep my x coordinate the same. So my x coordinate is going to be 2. But my y coordinate is going to become opposite. So instead of positive 4, it's going to be negative 4. All right. So doing the same thing when you reflect over the y-axis, your x now becomes opposite, and your y it stays the same. So I'm going to use 2, 4 again. When I'm reflecting over the y-axis, my x will now become opposite. So the opposite of positive 2 is negative 2. And my y stays the same. So 4 stays the same. Okay? So that's it when you're reflecting over the x and y axis. Remember, whatever axis you're reflecting on, that is the axis is going to stay the same. And the other one becomes opposite. All right, now we're rotating 90 degrees. When we're rotating 90 degrees, remember we can rotate clockwise or counterclockwise. When you're rotating 90 degrees, it doesn't matter if you're rotating clockwise or counterclockwise, your x and your y values are going to switch places. Okay? So that's what this means right here. So this is my original x and y. They're going to switch places. All right? If you're rotating 90 degrees clockwise, because clockwise is to the right, the way you read the clock, because it's to the right, whatever is to the right is going to become opposite. So the x is to the right, my value here is going to become opposite. All right, so let me give you an example for that. So I'm still using 2, 4. These are my original coordinates. I'm rotating 90 degrees clockwise. The first thing I do when I'm rotating 90 degrees clockwise is I'm going to switch my x and my y values. I'm going to switch their places. So it's going to be 4, 2. And because I'm rotating to clockwise, I'm going to change whatever is to the right. I'm going to make it opposite. So it's going to be 4. Opposite of positive 2 is negative 2. All right. So 4, negative 2. That's what happens when I rotate 2, 4, and I make it clockwise. If I'm rotating 2, 4 counterclockwise, the same thing happens, because anytime you rotate 90 degrees, you have to switch your x and your y. So I'm going to switch my x and my y. And because counterclockwise is to the left, I'm going to make whatever is to the left, I'm going to make that opposite. So opposite of positive 4 is negative 4. And then I'm going to keep that too. So when I rotate 90 degrees counterclockwise, I get that. When I rotate 90 degrees clockwise, I get that. Okay? So that's it about rotating 90 degrees. Now we have rotating 180 degrees. With 180 degrees, it doesn't matter if you rotate clockwise or counterclockwise. It doesn't matter. You're going to get to that same point. So anytime you rotate 180 degrees, remember both your x and your y values are going to become opposite. So if it's originally 2, 4, it's going to be negative 2 and negative 4. It's just that simple when you're rotating 180 degrees. All right. All right. So the next thing we're looking at is our angles. Okay. Before we get started on angles, I want to talk about transversals first. So a transversal is a line that crosses two or more lines which may be parallel. So these are our two parallel lines, which makes this line right here our transversal. Okay. All right. Now, there's one, two, three, four, five, six, seven, 8 angles here, and they all have different relationships. What we're looking at, this word congruent, we know that congruent means that it's the same, correct? All right. So I'm looking at angle 1 and 2. When you have angles that are side by side like this, we know that those angles are supplementary because they add up to 180. So angle 1 and 2 supplementary, angle 4 and 3 and 4 supplementary, angles 5 and 6, 7 and 8. Okay. And also 2 and 3, 5 and 8, 6 and 7, 1 and 4, because when you add them together, they add up to 180. So those are supplementary angles. All right. And then we have corresponding angles. Corresponding angles are angles that are in the same position. A pair of angles in the same position relative to the parallel lines and the transversal. Okay. So I'm looking at, if I'm asking you what is the corresponding angles for angle 2, I'm looking at the angle that is in the same position on the same side of the transversal. So this 2 is on the right side of the transversal and is on top. So my corresponding angle for angle 2 would be angle 5 because it is also on top on the right side of the transversal. So the corresponding angle for angle 3 would be angle 8. The corresponding angle for angle 1 would be angle 6. For angle 4 would be angle 7. Those are corresponding angles. Okay. Now we have interior angles, exterior angles. So our interior angles are angles that are inside the two parallel lines. These are my two parallel lines. All the angles that are inside are interior angles. So I have angle 3, 4, 5, and 6. All 4 of these angles are interior. Now we have alternate interior angles. Alternate interior angles are angles that are on the opposite side of the transversal but are still on the inside. So 3 and 6 are alternate interior, 4 and 5 are alternate interior. And then you also have same side interior angles, which means they're on the same side of the transversal, but they're still on the inside. Okay? So that's everything we need to know about interior angles. Now, exterior angles are angles that are outside of the two parallel lines. So this is my two parallel lines. Exterior angles are angles that are on the outside. So angle 1, 2, 7, and 8 are exterior angles. So we also have alternate interior angles and alternate exterior angles. Okay, so my alternate exterior angle will be angle 1 and angle 8 because they're both on the outside and they're on opposite sides of the transversal. Okay. And you also have same side exterior, so 2 and 8 are same side exterior angles because they're both on the same side of the transversal, but they're on the outside of the two parallel lines. Okay, so that's pretty much everything you need to know about angles. Now let's get to the Pythagorean theorem. Remember, Pythagorean theorem is the formula is a squared plus b squared equals c squared, and we know that the legs are a and b, and we know that the c is always your hypotenuse. And we use the Pythagorean theorem when we're working with right triangles. Okay, now remember the easiest way to find what your c is, which is always going to be your longest side, is by drawing an arrow from the right angle, and it will lead you right to your c. Okay. So let's do one problem with this. If they give us our two legs, so let's say this is 2, this is 4, and they're asking us to find our hypotenuse, all we have to do is put it into our formula here. So remember, it doesn't matter what you say these legs are. So I'm going to say my leg A is 2, and my leg B is 4. So 2 squared plus 4 squared equals c squared, and I'm looking for that c squared. I'm looking for my hypotenuse. So 2 squared is 4, 4 squared is 8, equals c squared. 4 plus 8 is 12 equals c squared. And then when I get here, I want to find the square root of 12. So my c is going to be the square root of 12. And that's going to be my hypotenuse. Okay? That's pretty much all I want you to know. If you have any questions about this, make sure you send me a message while you're doing the quiz, and I'll be able to help you out.